All right, today we're going to be talking about patterns in math, and we're going to specifically be talking about how we can find rules for patterns and then extend tables to show those patterns based on the rule we just created. So in order to be able to write rules for patterns, we have to first understand what patterns are. You guys all know what patterns are. Patterns are things that are repeated over and over, whether it's numbers, shapes, letters, pictures. So here's some really simple examples. In this first one, pumpkin, leaf, leaf. Pumpkin, leaf, leaf. You could easily tell me that next is going to be a pumpkin followed by two leaves because that is the pattern. That is, this pumpkin, leaf, leaf is what's repeated over and over and over. Same thing, apple, acorn, acorn. Apple, acorn, acorn. You can tell me that next is going to be an apple and two acorns. So these are some really simple examples of patterns, but we have to know what patterns are in order to be able to write rules for patterns, because we're going to make it a little more difficult today. So take a look here. This is a very important statement up here that needs to be remembered when we're thinking about patterns. And it says, whenever there is a consistent mathematical relationship that links numbers in a pair, it's possible to write a rule for that pattern. So what does that mean in kid terms? Well, we need to really know what the word consistent means. Consistent means every single time. Doesn't mean sometimes it works, sometimes it doesn't, like the weather. Sometimes it's sunny, sometimes it's rainy. Consistent means every day. Think something consistent would be every day the sun comes up. Sometimes it might be behind the clouds, but every day the sun comes up. That's something that is consistent. So in order to be able to write rules for patterns, we have to have a consistent relationship that links numbers. If it's not consistent, it's not going to work. So I have two tables here, and we're going to take a look at them and find which one of these has a consistent relationship, something that works every time that we can be sure of, and something that is not consistent that we can't really count on. So let's look at table A. So on the left, I have 2, 3, 5, and 10. And on the right, I have 5, 6, 8, and 13. So now what I need to do is I need to look for a consistent mathematical relationship. So I'm going to start on the left, and I have 2 to 5. So I need to think to myself, well, what could be the relationship between 2 and 5? And I'm going to think about all my operations, addition, subtraction, multiplication, division. And the first thing that I notice is that from 2 to 5, I'm adding 3. I have to now go to the second row in my table because I can't say the pattern is plus 3 if it's not consistent. Second, I have 3 and 6. Well, that also fits that plus 3 plus 3. 3 plus 3 is 6. 5 to 8 plus 3. 10 to 13 plus 3. Because it was a consistent relationship, it worked for every single pattern in this table, I can go ahead and say that the rule for this table is plus 3. I can create a rule because I had a consistent mathematical relationship. Let's look at table B. 2 to 5, starting with the same thing. And I'm going to do the same thing I did with that first table. The first thing I notice is that I'm adding 3. But in order for it to be a pattern and for there to be a rule, it has to be consistent. So let me look at the second one, 3 to 7. Well, I noticed that 3 plus 4 is 7, whereas my first one was plus 3. In this third one, I go from 1 to 3, that's only plus 2. 4 to 8 is plus 4. So I had 2 plus 4s, a plus 3 and a plus 2. I don't have a consistent mathematical relationship here that links these numbers. So for this, I can say that there isn't a rule that I could write that would make a consistent pattern here. If I were to add a number to this bottom table, to table A at the bottom, and I were to put a 12 there, you could tell me what would go in the right column because we figured out that there was a consistent relationship every time we were adding 3. So if 12 were on table A on the left, you would know that 15 would be on the right because that's plus 3. In my bottom table, there was no consistent relationship. If I would add a number at the bottom, I would have no idea what to do on the right because there wasn't a consistent pattern. So we can't create rules unless there are consistent patterns. So we're going to look at 3 examples We're going to see if we can find the consistent mathematical relationship, see if we can create the rule, and then maybe even solve for some of the blanks that are in tables. So let's look at this first one. We have a table that shows Daniel's age and Stephen's age. So the first thing I need to look at is what is the relationship. And I like to think about it in terms of words first. What am I looking at? Okay, well, I know that this table is showing me two boys, Daniel and Stephen, and it's talking about their ages. So that's going to be what I'm looking at. Now I'm looking for a consistent mathematical relationship. So I'm going to start my table. Looks like when Daniel was 12, Stephen was 18. What relationship do I see there? Addition, subtraction, multiplication, division. First thing that jumps out at me is addition, because I'm going from small to big. And I notice that I'm adding 6. Okay, but it doesn't necessarily make it a pattern unless it is a consistent relationship for the entire table. So I'm going to go to the next blocks. 17 to 23. Again, I notice a plus 6 relationship. So these two were consistent. Now here it gets a little tricky. I have Daniel's age, but I don't have Stephen's. I'm going to skip this box for now. I'm going to go to this box that has both. Daniel is 8, Stephen was 14. The relationship there again is plus 6. Because I've gotten, and I can't do this one yet because it's a blank. 3 out of the 5 have been a consistent mathematical relationship. I think at that point it's safe to assume that the rule and the relationship are going to be, the relationship is consistent. So because I have a consistent relationship, I can make a rule. So what did I do on each of these boxes? What was their relationship? Well, each time I was adding 6 to Daniel's age. So I can go ahead and say that the rule is probably going to be plus 6. Now that I know the rule, I can fill in these blank boxes because I know that every time I see Daniel's age, I'm going to add 6 and get Stephen's age because the pattern was consistent. So if I know Daniel's age is 32, what could I do for Stephen's age? We know the rule is add 6, and I know that 32 and 6 is going to give me 38. Now this last one is slightly trickier. We know the rule was plus 6. So if I do 20 plus 6, I get 26. But if I put a 26 here, that's going to make my pattern not consistent anymore because every time I was taking Daniel's age and adding 6. Daniel's age and adding 6. Well, now if I take Daniel's age and add 6, I don't get 20. So how am I going to figure out this box? Well, if I know that Daniel's age plus 6 gives me Stephen's age, I can go ahead and solve this problem because I don't know Daniel yet, but something plus 6 gives me Stephen's age, which I know is 20. So because I have this, I can fill in this blank for Daniel because I know my addition subtraction facts. So if something plus 6 is 20, well, I know I can do 20 minus 6 because addition subtraction are opposites. 20 minus 6 is 14. And that should work. Daniel's age plus 6 gives me 20. And now my table has that consistent mathematical relationship every single time I'm adding 6. Okay, let's look at another one. Okay, we have Nelson and Pam. So again, we're looking at their ages. And I need to look for that consistent mathematical relationship. So it looks like when Nelson is 4, Pam is 2. I notice 2 things here. One, well, 3 things. I notice we're going from a bigger number to a smaller number. So it's either going to be subtraction or division because multiplication and addition get bigger. And then I also notice I could do 4 minus 2 is 2. And I also see the relationship of 4 divided by 2 is 2. Now I need to decide which one of these is going to be my consistent mathematical relationship, minus 2 or divide by 2. So to do that, I'm going to look at the next number in my table. I have a 10 and an 8. and I said I did -2 here. So I'm looking for a consistent relationship of either -2 or divide by 2. And I noticed right away 10 and 8, 10 divided by 2 is 5, but 10 minus 2 is 8. That's a consistent relationship between both of those. Let me make sure it works for my third one. 8 and 6, that works for -2. So I think I could go ahead and say that the rule for this table is going to be -2. So because I know the rule is -2, I can go ahead and I could extend this table. And when we extend a table, it just means that we're adding more numbers. So I could say if Nelson was 12, what would Pam be? Well, I know that my rule is -2 because I had that consistent mathematical relationship, and 12 minus 2 is 10. Okay, let's look at one more. So the first thing I need to think about is my relationship. What am I looking at? Well, it looks like I'm looking at teams and players. Could be basketball teams, baseball teams, doesn't matter. So this is telling me when I have 4 teams, there are 20 players. What relationship do I see there? That's the first thing I need to look at. I see 2 things. Well, 3. One, I know I'm either doing addition or multiplication because this 4 to 20 got bigger. That's either addition or multiplication. I see an addition relationship of plus 16. I see a multiplication relationship of times 5. 4 times 5 is 20. Now I have to look for a consistent relationship between these numbers. So let me look at 3 teams. 3 teams would be 15 players. Okay, I know I'm still doing addition or multiplication, and when I look over here, I see the times 5 rule works. That plus 16 rule isn't going to work here anymore, but times 5 does. Let me check it out with the 6 and 30 as well. 6 teams times 5 would give me 30 players. So I think it's safe to say there that the rule is going to be times 5. Now I have to go back and fill in the blanks on this table. And it's going to be much easier because I know the rule. So if I have 5 teams, how many players am I going to have? Because of that consistent mathematical relationship that I found of times 5, I know all I have to do is 5 times 5 gives me 25. That still fits. This makes this table consistent. 8 teams. I'm going to do the same thing, times 5. 8 times 5 I know is 40. Last one's a little bit trickier because I know my rule is times 5, but every time I've done times 5, I've taken the number of teams times 5. Well, I don't know the number of teams. I only know the number of players. So I'm going to think about this as the number of teams, and I know when I do the teams times 5, in this case, I'm going to get 50 players. Now I know that multiplication and division are opposites, so I'm going to be able to use my division facts here to help me. So something times 5 is 50. Well, I'm going to do 50 divided by 5, and I know 50 divided by 5 is 10. That works because it fits that consistent relationship of times 5 as the rule. 10 times 5 is 50. If I were to extend this and say, what about, oh, I don't want to do that much thinking. Let's do 9. 9 teams. How many players would there be? I could easily follow my rule. Times 5. 9 times 5 is 45. So the important thing to remember about patterns is you have to find the consistent mathematical relationship between the 2 numbers, and that's going to be what allows you to extend those patterns for tables. So hopefully, after watching this video, you're able to find rules for patterns by looking at their relationships, and that you could then either extend patterns or solve for things within those tables based on the patterns you found.